Okay, this is our optional lab slash assignment accompaniment video. So I do want to talk through a few things. I have a list here of 4 or 5 things I wanted to demonstrate, just to give people extra help if they want it. Yeah, so the first thing that you have to do in this lab is fill in all the formulas in green. I've already done that here, and then here's the check on. I believe in the lab handout it tells you that you should end up with a negative 165,200 at a price of $2, and then that's one way to know you have everything correct. And then it gives you another dollar value, I think 0, and that confirms it too. So those two match up. And I think there's a note in there that says, be careful about using $0 as your check, because you could have a lot of things wrong, and the 0 dot, because the price is 0, it won't. It may not reveal that. 0, 1, bad choices for a benchmark because, well, they're both the identity. So when somebody taught you way back in the day that 0 and 1 were the key numbers for 0 for addition, right? Identity. Add something to 0 and you get the number back. You get the identity back. Multiply something by 1 and you get that back. Well, those properties, it turns out, end up masking a lot of problems that we might find in a model, especially one like this where there are quite a few formulas that depend on one another. So that's just a minor point. Yeah, so the real point of the assignment, and one of the things I wanted to emphasize, was setting up scenarios. So we have this base model that does calculations, and we could sit here and make any changes we want in this column. We could decide that the price is now $3 and look at everything, and then we could decide it's $8.80 and look at everything. But every time we do that, we're changing a bunch of things. And so what's nice when you can keep the entire model in one column like this, and especially these kind of profit models where you're working out of a profit loss sort of components, is you could just copy and paste the entire model. I'm going to do that by hitting Control C, and then I've got 5 scenario columns listed over here, and I'm going to paste it into all of those. And that's really what the lab instructs you that you should do. And then I think it tells you, I don't really remember what values, but something like, say, 7, 8, 9, 10, and 11. And then maybe look at profit, right? How do the profits change as the price changes? So simple enough. I don't think anybody's going to have any trouble with that. I just wanted to do it as a quick demo, and really then I wanted to make a very, very important point, which is when you do this, when you set these 5 scenarios up, only be changing one thing at a time, because everything about the pattern that we're looking for here in profit versus the change in the price depends on the fact that we have a ceteris paribus going on, right? All else constant. This is the change in profits from a changing price, all else constant. If you mix in other changes in the unit cost and all those things, we are not separating those things out. And so scenario analysis like this, it's really important to be doing one thing at a time. There was another setup, and so we could if you continue on through the handout there, it says that you should make a new set of scenarios. And so I'm going to do that by just copying this model that already has 5 scenarios set up, and I'm just going to call it demand or something. Because instead of looking at 5 different prices, it says set all the prices to $9, which is really kind of the benchmark price that we find. As you go through the lab, you'll see that $9 is pretty close to the best price. It's the best price you can find. Be sure that when you make that change, you end up with something down here that's constant across all of these. And then what it asks us to do is go through and change all of these parameters, okay, all of the demand parameters. And it tells us to do it in a specific way. It says to set this one equal to 80% of the base parameter, and we still have the base model over here. And then set this one equal to 0.9 times this, and then set this one equal to this, and then set this one equal to 1.1, a 10% increase, and then set this one to 1.2, 20% increase. Okay, and then you go through there, and now we're looking for us again around sort of our base scenario, or our sort of base assumption on the demand slope. These are all of the changes. This is how having a demand slope closer to zero versus farther away affects this. And so your questions would be, why is it, this demand slope is getting larger in absolute value, the quantity adjustment gets larger, the profits fall. As we go in this direction, the demand slope gets closer to zero, right? Smaller in absolute value, less responsive consumers, our profits go up. And that just sort of confirms something from basically any sort of production profit maximization theory. Says the steeper the demand curve you face, right, the more inelastic, then the more the better off you are with price increases, right? So at the same price, revenue will go up because there's just less demand response to you setting the price. Yeah. So we have 5 scenarios at $9 solving for different demand slopes. But what the lab instructions are trying to get you to key on here is $9 the best price for these? So this base assumption here, the first time we went through all this and we change it and we get sort of the confirmation of the result we want, so this slope of 4,000 led us to believe in this model. I went back to my first one, comparing these profits, $9 was the best. Well, if you wanted to come up with a model that says, how does the demand slope affect profits, you could do it this way, but this is the one thing that you could do to improve this while violating the ceteris paribus conditions. And that would be to actually solve each and every one of these models for the best price and for the maximum profit. And so just to do that, to start with, we would come down here and we would go to data, and then we would go to solver, and we would go here, and so we would set F24 to be the objective cell, and we're going to maximize, and we're going to do it only by changing the $9, only by changing the price, and just use GRG nonlinear is fine, and click solve, and solver finds that 891 gets paired up with this demand slope as the best price. This is the optimal profit. Move over 1, go to solver again. Now we're going to select E24, and the variable we're going to change is E5, that price. Click solve, solver finds it, it says it converges, and so the price we can set is higher. So I want to be clear that when we're talking about scenario analysis and changing one thing at a time, that's sort of what we're doing here. We are saying I'm going to change one thing at a time, and that is the demand slope coefficient. This is the one thing that we're changing. The profit and price are moving together, and we're saying what goes on, this sort of pairing of best price and best profit level. Because what are we missing? Well, if we just use the straight calculation of profits, the $9 price is something that as soon as we ended it up, if somebody told us we had the wrong demand slope, we would want to adjust it. And so really what I'm saying is the thing that's changing is the slope. The response, or the thing we really should be checking, is what's the best price to charge as the slope changes. And then as a consequence of us changing this price, the profit just happens to adjust. Okay? And so it gets a little tricky, and the lab assignment tries to tell you that we are doing one change at a time. It's just the model we're solving isn't. It's the difference in looking at this column right here and saying this is a complete model, right? When in fact it's really just an accounting model. It is not an optimization model. To get this scenario 3, scenario 2, scenario 1, the base column, any of these, to treat them as an optimization model, every time you make a change, you should go to solver and choose the best price profit combination, right? Or choose the price that maximizes the profit. And so it's just a slightly different way of thinking about what is the model in this column. Is it the optimal, or is it just holding strict at a $9 price? Okay, and so you can see here the optimal price is going up as you move to the left and falling, and the profits are going up. And it just gives us a better measure, and there's a graph in there that shows you the difference between sort of the non-linearity of getting the optimal result versus the linearity of getting of just doing a straight analysis across $9 options. Okay, I think that gets us through that, and you can work from that how you please. The last thing I want to get to is in your assignment, you're basically told, okay, you did some analysis for us on demand. Now, not on demand, but an analysis of demand, right? I've got some, and we're reviewing your work and deciding we should go out and put together a demand study, but while we're at it, you be the one to tell us if this data on processing costs should cause us to change what we're doing in our model. And so you're asked to do a regression, and I believe you've already had a class in this, so that's something that I believe it's okay to expect you to do. But really what we're trying to say is, how do processing costs respond to the quantity, right? So if we go all the way back to our first spreadsheet model here, you see there's a processing cost, $2.05 for every unit of the quantity. Okay, so basically we're here, we have this information, and we should try to see if $2.05 is the right change in cost per change in quantity. And so to do that, there are a number of ways to do regression here. You could go to data analysis and scroll down and click regression and click OK, and then it lets you put in the Y values, which are the cost. That's what we're trying to explain. And the X values, where you're using the quantity. And so we're trying to see how cost changes quantity, and I'm just going to let the output range go right there. And that's really all there is to it. So we end up with 3.375. Okay. So that is the change in cost per change in unit quantity is almost $3.40, quite a bit bigger than the 205 we were using. If you're inclined, you might look at these. The p-stat is very small. It's a good fit. The one thing you might be bothered by is this coefficient right here on the intercept. It's a negative coefficient. So there's a line, if we were to plot this, that has a negative intercept and basically says you have to get to a certain quantity before we start charging you anything. The other way that another way to get a regression equation out of Excel would be to just plot it and use the trend line. So we might go to Insert, and if you take this type of graph, XY, and then let's check the data and see what it looks like. Select data, edit, edit. For the X values, we end up with the column A, and for the Y values, we end up with column B. So that looks good. Got the right thing there. Let me make this a little larger. And so one of the things you can do when you have a plot of data like this is just right-click on it, put Add Trend Line, and then over here in the trend line options, you could say display the equation on the chart, display the R squared on the chart. And you see that the equation comes up the same when I add it there. Okay. And so what is going on here? You see that this straight line fitting through here is going with this well below 0. And that could be a problem, right? That's not the way we think of this variable cost equation sort of working. So we've looked at 2 ways to do this estimation, and we're worried a little bit about this intercept, so we might, I'm done looking at the trends, I'm going to get rid of it. You might consider taking away the intercept or forcing the intercept to be 0 so that you're getting the best fit. Sorry, I wasn't done with that yet. So you're getting the best fit that also passes through the origin, right? So you'll get the minimum or the best regression line under a constraint, right? The constraint that you pass through here, so that at 0 quantity, the processing cost is 0. Anything else, right? You're getting some freebies here, and so there's reason to believe that, one, this probably isn't linear. If we were to track it, it probably has some kind of flat and then goes up, and you know, just depends on the efficiency of the machine or whatever. But it certainly wouldn't be negative. We wouldn't be taking it, getting negative values for it. So that's a reason to question the slope. So one of the things you might do is, now I'm going to ditch this, go back to your regression and click on the option here for constant is 0, and that will force you to get a new result with 2.47, much closer to the value we already have. It passes a p-value test, and you end up, you know, not getting any results here for this because we constrain that to be 0.